Three concentric spherical shells have radii A, B and C, A less than B less than C, and have surface charge densities sigma, minus sigma and sigma respectively. If VA, VB and VC denote the potentials of three shells, then for C equal to A plus B we have A, VC equal to VB not equal to VA, B, VC not equal to VA, B not equal to VA, C, VC equal to VB equal to VA, and D, VC equal to VA not equal to VB. Here in this question we are given three spherical shells which are concentric and have surface charge densities sigma, minus sigma and sigma. Their radii were also given. Which are A, B and C. And now we have the potential formula which is V is equal to KQ by R, and we also know that surface charge density sigma is equal to charge by area. So we have here we can write charge as surface charge density into area. So we can write it as K into sigma into 4 pi r square by r. And the capital R represents the radius of the sphere and small r the distance. So potential of A we can write it as, for the first shell which is with radius A, we have K into sigma into 4 pi A square by A, and similarly for B and C. And since B and C are outside shell A, shell with radius A, we can use the respective radiuses as the distance. So here we can cancel A and A from denominator and numerator, and we can simplify and write this as K sigma 4 pi into A minus B plus C, which we obtain by taking these things common, and A, B and C are not common, and the minus symbol over here is taken as minus B. Similarly we can find VB and VC also, but for VB, since for the shell with radius B, shell with radius A is inside it, and we know that the potential inside the shell is the same as potential at the surface of the shell, we take the distance r as small b, radius B, for potential from a sphere with the shell with radius or radius A also. So we have VB is equal to same common, so we have 4 pi K sigma into, we know it is r square by r, in which capital R is the radius, so here radius will be the same, A square, but while taking the distance, since we are taking the potential of the B shell and A shell is inside B, the distance will be still B radius only, since it is inside, and we know that inside and surface till it reaches its radius it is constant, it will have same distance. Here we are taking the potential of shell A from B, so we'll take a radius B as the distance, but for the rest of the potentials it is the same only, plus minus B plus C. Similarly in the case of C, we'll have 4 pi K sigma and A square by B same. It is not A square by B though, we are taking the potential from shell C, so it will be A square by C, and since B is also inside the shell C, here also we'll get B square by C, then plus we'll have C square by C, which is C itself. We can simplify VC, which is equal to, we can take A square and B square together under above the denominator C, but we know A square by B minus B square is equal to A plus B into A minus B as per identity. Now we have A plus B, A minus B written, and we are given that A plus B, C is equal to A plus B, so this C we can take it as A plus B and cancel C and A plus B, and we obtain A minus B plus C, which we can identify that it is the same as VA. So we have VA equal to VC, but both of them are not equal to VB, which we have from our option D, VC equal to VA not equal to VB.